solenoid that is 112.58 centimeters long with 1,489 loops to produce a magnetic field within the core equal to Earth's magnetic field, 7.79 times 10 with the power of -5 Tesla. What current is required? Show all steps necessary to prove the solution. And CP 708.
Yeah, all right. That's 10. Good job. All right, so we're going to go ahead and continue on. I'm going to rock and roll with the problem. But if I were you, I'd open up that wonderful book that's in front of you. It's not just there to collect dust or be a paperweight. It actually has knowledge inside. So turn to page 789 real quick. We're robotics students, so we're doing the upper levels of physics in this book. 789. And last time, we talked about solenoids and where they exist, right? So basically, on 789, it starts a chapter called Magnetism and Electric Currents. What's wrong with that? You're looking crazy.
Oh, because on here it says 796.
796. Oh, 789 is the start of the chapter. 796 is where I was going to lead you to.
Oh.
Yeah. She's like looking at it crazy. So if you look here, we're going to go to 796. Is that where it is? Oh, no, it's not 796. That's an error. Now I'm thinking that's for tomorrow. That's an error. So go to page, again, 793, right? And what you want to do is you want to look at the problem from the past. Now, we got to do something different in terms of this problem. We have to solve for something else, okay? Anybody can guess at what we have to solve for before I start writing? I'm going to start writing the problem out. See if anybody can guess at what we have to do. You're going to look at the example, but it's a little different from yesterday. So what we do. And then the name of the equation you're going to use is the magnetic field of a solenoid, right?
We got 10 minutes this time.
Okay, and I'm going to do what I can, sweetheart. She said 10 minutes. She said it like a little baby. All right, so what do we do? You're going to use this equation. I'm not going to write out everything because you don't have a lot of time. But here. You have your B field. I'm on page 793 if y'all want to write down the notes real quick. So the B field is equivalent to, what was it, mu naught times, parentheses, we have N divided by L, right? Times I. Okay? We know what this is. This is Tesla's, right? That's what it's measured in. This is measured in a Tesla meter amp over amp. We know this is the number of our loops, right? And this is current, I, right? Amps. We need to now do our no. And I'm gonna move as quick as I can because the coordinator was right. I'm about to get kicked out of class. So y'all can go home, but y'all still need to finish this on your own. So known, unknown, and let's set up everything. And for the sake of time, I'm not going to open the floor up for discussion to say what this is and what that is. I'm just going to tell you what it is. So we go through the problem slowly. And everybody's problem looks similar to mine's on the screen here, or is it different? Before I move too quick. Does it look the same numbers as your document? Okay, you scared me. You said that like hesitantly. Yeah. Is it the same or no? Okay, because you said it like, All right, so first things first, what do we have in our known values? Well, we know we have 112.58 centimeters long. That's length, right? Remember, we cannot use for length centimeters. We have to use meters, right? So we got to convert that from centimeters to meters. So that's going to be L is equivalent to 112.58 centimeters. The next step is convert that. And remember what I said, centa means 10 to the second, negative second power, right? And that's going to be times 10 to the negative 2 power. And now it's meters. What else we got? I'm moving at Sonic the Hedgehog speed if I can, y'all. So we got a number of loops. It says 1,489 loops. That's our N. So N is equal to 1,489 loops. And then what else do they give us? Well, they give us guess what? The B field, because it says the magnetic field. So that's B is equal to this number here at 7.79 times 10 raised to the negative 5th power, and that's Teslas, leaving our unknown value of current I to be found. Now I know y'all gonna look at these equations and be like, how do we get I by itself? It's just algebra. Relax, 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 okay? So you're gonna box this off. I'm gonna show you the algebra as fast as I can. But you gotta do it on your own in another problem that you do. And the problem, the other you do problem is similar to yesterday's problem, so it should not be hard on you. All right, so what do you do? Step 1.
Oh, I could just go back to my node.
Solve for I, right? Or amps. You're gonna rewrite the equation. And B is equal to, your notes change up just a little bit. Oh, we forgot mu, right? Mu naught. That was 4 pi, I think it's times 10 to the negative 7. And that's a Tesla meter amp. Just so we have everything, right? And we got N divided by L times I, right? And then what else do we want to do? Let's take it slowly. We're going to write this again. Whereas B is equal to mu naught times N over L times I. And again, do not freak out. You got to get I by itself. So just take it slowly. So first things first, I'm going to go ahead and isolate mu naught on both sides. I can just divide mu naught out. If you do one side, you do the other, right? This allows me to cross out my mu naughts. Rewrite. End up with B over mu naught is equivalent to, write that together, N over L multiplied by I, right? And we're getting closer to I. So you just do one simple step. I'm gonna rewrite. And I'm not gonna lie, the rest of it, I'm gonna try to write as much as I can. I want y'all to try to do it on your own by solving it, because the rest is just plug and play. So I'm gonna rewrite this like this. There's a reason I'm leaving a space here, because you kind of already know what I'm about to do. So how do I get this off of I? I do the inverse of that fraction algebraically. So I'll just say, hey, if I just multiply this by its inverse, that'll be L over N. It allows me to cross these two out. What you do to one side, you gotta do to the other. I can now cross out these and cross out those, leaving a new equation, let's write it correctly, of I is equal to, just write what you got, B over mu naught, right? That's one fraction by itself, multiplied by another new fraction of L divided by N, and that'll give you I. All right, so we'll put in the numbers. How did I do? Woo, I did that in 6 hot minutes. 4 minutes left, Courtney. How you like that? Anyway, I never doubt a physicist, a black one at that. You guys are plugging your numbers, and we have the first fraction that looks like our B field. That's 7.79 times 10. I smoked that board. That's a Tesla. And I'm not talking about anything else while you crack jokes. I'm talking about this marker. It's got, anyway, mu naught on the bottom. All right. Let's think of 7. There's a Tesla meter amp here. Close parentheses, multiplied by another set of parentheses. Make sure you use your calculator correctly. We have our length of 1,000. The length goes up top. So that's going to be the centimeter, not the centimeter, but the regular version. We converted it. That's 112.58 times 10 raised to the negative 2 meters. That's going to be divided by what? Our number of loops. That's 1,489 loops. It's dimensionless, as we know it's loops. You'll see your meters cancel, your Teslas will cancel, and eventually all you have is the amps, because the amps will slide upstairs. That's an inverse fraction in the bottom of a fraction. So you end up with I is equal to, did anybody figure it out, or should I just go ahead and number crunch it for you?
No correction.
That was Courtney. I need a calculator smart behind. She's gonna say it and then I help me out. I just get keyboards. Click, 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 click. Y'all sound like little number munchers over there. Just click, 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 click. That's all I hear.
This is how, is that a 7.79 for
Where you at?
of those?
For the knowns, 7.79.
Oh, okay.
Okay. So let me go ahead and do this. You hit the fraction button. Make it easy on yourself. Because you got to do this in your you-do. And hit the first fraction button. That made me a fraction. I just plug everything in. 7.79 times. Hit the 10x button. It gives you a 10 in a box to type in -5. Then press down. You're going to hit 4. Pi button is at the bottom there. You hit that. And then times 10x button. Again, -7. Come out the fraction. And we'll say times another fraction. Put it there. And it's going to be 112 in the top, 0.58 times 10x. Hit -2. Come down. 1489. Uh-oh, I didn't come down. Slow down. 1489. And you get this here. And it is I is equal to, wrong color, 0.04, let's say 7. I hear rush in the hallway. That means we're about out of time. And it's measured in amps. Oh. I'll take a picture of it for those that didn't have enough time to type. Yep, I beat you according to 10 minutes. That boy, that boy cold, that boy cold. She said, yay. All right, so I'm gonna take a picture of this and put it in Nesby. You kind of get as much as you can. If you didn't get it from the picture I give you in Nesby, and you still are responsible for your you do and do now questions, as well as exit slip. Speaking of exit slip, let's go back and see if somebody can get 10 points. And it's for this. Does anybody want to read that for 10 or no? You gotta read the middle and the side. Renee gives me the look, the side eye, so that's a no. Sanchez is like, okay. You guys like, I'll take it. Okay.
Exit typing term of the day is permeability.
Permeability.
Of free space. And the word of the day is vertical.
Yeah.
Gotta read that one over there too, bro.
Students
be able to. You almost said swapped. Students be able to.
Mathematically calculate whether the point between current carrying wires is attractive or repulsive. Apply solenoids, magnetism, and electric current analysis is on part 2.
Awesome. Well said. Okay, I'm gonna take a picture and we get out y'all way.
It says